Hello, my name is Sawan Maniri Chun. This is my fourth video assignment, and it will be on impulse and momentum. Let's get right into it. First off, we have the problem statement, and it is, in a game of boules, a man tries to knock his opponent's ball away from the jack. His ball collided with his opponent's ball at the trajectory shown on the left side, hand side here, with a velocity of 2.5 meters per second. We are to find the final velocity of both balls after the collision. We are told that the coefficient of restitution is 0.65 and that both balls have a mass of 0.92 kilogram. First off, we gotta see how we have to approach this problem. From the graph on the left here, we can see that the contact plane of the collision is in the y direction, and because of that, because y direction is contact plane, we know that the velocity components in the y direction will stay the same after the collision. So because of that we get these equations here. The first velocity of the first ball in the y direction will be equal to the second velocity of the first ball in the y direction, which will be equal to the negative initial velocity times sine 30. And for the second ball, we have the first velocity of the second ball will be equal to the second velocity of the second ball, which will be equal to 0, as it started from rest. With that with that over with, we can move on to the next part, which is the line of impact. Here we can see that the line of impact is in the x direction. Because of that, we can tell that the velocity components in the x direction are related by the coefficient of restitution and the conservation of momentum. And these are its equation here. This first equation here is the conservation of momentum, which is the mass times the first velocity of the first ball plus the mass times the first velocity of the second ball will be equal to the mass times the second velocity of the first ball plus the mass times the second velocity of the second ball. Of course, all this will be in the x direction. And here we have the equation of the coefficient of restitution. It will be E equals the second velocity of the second ball minus the second velocity of the first ball divided by the first velocity of the first ball minus the first velocity of the second ball. Now that we have all that equations sorted out, we can go straight to solving the problems. We can plug the numbers we have into solving the problem. First off, for the y direction, as we shown in the equation earlier, for the velocity in the y direction of the first ball is the same, which will be equal to negative 2.5 sine 30, and we get negative 1.25 meters per second. And the y velocity of the second ball will be equal to 0 for the first and the second velocity. Moving on to the conservation of momentum, we have here the first velocity of the first ball in the x direction times its mass, and because the first velocity of the second ball is equal to 0, we'll just put it as 0. So we have this equals to that. And we can cancel out all of the mass out, and we will have negative 2.165 equals to the second velocity of the first ball plus the second velocity of the second ball. That will be our first equation. And for our second equation is the equation of coefficient of restitution. We will have 6.25 equals to the second velocity of the second ball minus the second velocity of the first ball divided by negative 2.5 cos 30. This is the same as this up here because because the first velocity of the second ball is equal to 0, so we only have the first velocity of the first ball, and we just multiply that by 0.65 and we will get negative 1.407 equals to the second velocity of the second ball minus the second velocity of the first ball. And now that we have these two equations here, we just plug it into a system of equation, and we can cancel out the second velocity of the first ball, and we can solve for the second velocity of the second ball, which will be equal to negative 1.786. And once we have that, we can plug that back into one of these equations, and we will get that the second velocity of the first ball will be equal to negative 0.379. And now that we have the velocity in both the y and x direction of both of these balls, we can just plug it into the Pythagoras theorem, and we will get the final velocity of the first ball will be equal to 1.306 meters per second, and the final velocity of the second ball will be equal to 1.86 meters per second. And that's it. That's the that's how you solve this specific impulse and momentum problem. Thank you very much for your time, and I will most likely see you again soon in the future. Thank you very much.